You say, well, we have genetically engineered plants tolerant of glyphosate. Why do we see these effects showing? You have to remember that there's nothing in the technology that does anything to the glyphosate or the Roundup that's applied. All it does is make it possible for the plant to tolerate that higher concentration of glyphosate, but the glyphosate is still moving systemically throughout the plant, reducing nutrient efficiency and nutrient availability, causes a yield drag. Don't know of a single evidence anywhere in the scientific literature or the hundreds of experiments that I've conducted and others have conducted with isogenic lines where the genetically engineered plant doesn't yield less than the normal plant. It's a universal factor that we see. So that when you disrupt the integrity of the genetic code in the plant, there are several things that happen, and one of them is that you have less nutrient availability, less nutrient efficiency, because you have a smaller root system in a genetically engineered plant, and also physiologically reduced efficiency. And then if you apply the Roundup, you have a compounding factor there that, as a chelator, also reduces that efficiency. The glyphosate's there for the life of the plant, so it also increases then that chemical in our food and our feed chain. Roundup Ready soybeans, and you can see that effect in this research done by Zovioli and Kremer. You'd expect a little less lignin because that's produced through the shikimate pathway. But here's why we're growing that plant. Photosynthesis is also less efficient, and your nutrient density in the amino acids and nutrient content is also reduced. The other thing that we've really been seeing impact lately is that it takes twice as much water to grow a pound of dry matter in a Roundup Ready plant treated with glyphosate than in a non-Roundup Ready isogenic line. That means that when you get a drought year, as we had in 2012, the differences become pretty extreme. You see these two fields of soybeans. It made a second application of Roundup here compared to, you move back a little bit from his first, and you see the sudden death syndrome coming in already at this time compared to the non-GMO across the fence row. Same environment, same weather, same soil type, but a difference in a very limited genetic chain. See the same thing with these two cornfields that are separated by a 60-foot gravel road. You see that increased water stress because it takes more water when you have the genetic engineering system in there. These are those two fields. You can see that 60-foot gravel road. But you see the impact then. Both of these should be 250 bushel yield. But at least this plant's going to work for you as hard as it can under the general environmental conditions. But you can see that compromising of drought resistance when you have the genetically engineered plant, the triple stack over there in this particular situation. And it's been demonstrated many times in replicated field plots. You see that same thing in this particular soybean variety. You see a 17% reduction in manganese uptake, 47% in zinc, and that'll change some with different varieties. Then you put the glyphosate out and you see that additional reduction in nutrient efficiency and nutrient uptake. You can see it in this research in Wisconsin, where you see the recognition that iron is less available in a high pH soil, so they developed iron seed treatment. And that brought them from 33 bushel to 56 bushel yield just with the seed treatment except when they put the glyphosate out, it's chelating that iron and also changing the soil biology. Took them from 33 down to 8 bushel, and with the iron seed treatment only brought them up to 19 because they didn't recognize that glyphosate is a broad spectrum chelator. If they'd also added manganese with that iron, my research would indicate that they'd have probably had at least 56 bushel, maybe even 65, because they probably weren't seeing a hidden hunger from the manganese on those high pH soils.